Alright, so I picked up one of these little oscilloscope boards, which I thought was pretty damn cool. This is the DSO138 Oscilloscope, and you can see that's what it is. Little board. You feed it 9 volts power. Comes with these little probes here, but you've essentially got a ability to read up to 50 volts on here. Let me just cut it on here. Booting it up, running from 9 volts. So right now it's still on the test signal, but just to kind of give you an idea of what you can do here. So you've got the selection button, which can cycle through your various functions. So starting at the top here is our time scale, so you can smoothly slide back and forth along the time scale here, which at the moment is 0.2 milliseconds. So if you need to slide over a waveform, get it on the screen, you know, that's how you would do that. Likewise, it just moved right over here to this 0 volt slider, which you can actually adjust that up or down. I don't really need to at the moment, so I'm just gonna skip past that. This is our time scale, so I can go all the way in to about 10 microseconds, then 0.1 milliseconds, 1 millisecond, 5 milliseconds, 10 milliseconds, 20, 30, all the way up to however many seconds I need. Let's keep that in about the 0.2 millisecond range there. So I can also set it to trigger according to a certain voltage level, which at the moment is just set at 0 volts. This is my trigger level here, which I can set. So you see I have that matched with the 0 volt level. So any signal that is above 0 volts is going to be triggered by the scope and is going to pick it up, which is what that LED is doing. So I'm not going to mess with that, but that's essentially what that does. So you have these basic options that you can adjust to give you basic functionality, and likewise you've got a certain level of sensitivity here. So right now I'm looking at this test signal at the 1 volt sensitivity, so I've got 5 volts per division. Now I've got 2 volts per division. Now I've got 1 volt per division. Pump that up. Now you can see at 0.1 volt per division, it's kind of going off the screen a little bit. Bring it up to 0.5 volts per division, and there you go. So it's pretty handy. Bump it up to DC. Now you can see I'm at about 3.3, starting from 0 volts, 1 kilohertz, about 50% duty cycle. So there you go. I mean, that's your basic functionality of what's going on. This is what you're going to be reading in a signal. So that's pretty cool. This is the little manual it came with. That's about it. Gives you a little bit of info on how to calibrate this. So one of the first things that you're going to do is calibrate it. I'll kind of go into that later. You can turn off the readouts to see the whole screen if you want. It's got a waveform save and recall function. There's a way to automatically readjust the 0 volt point if it's a little bit off. Your V position alignment. So, you know, fairly basic, but yeah. You know, for like 25 bucks, I feel like this is kind of a must-have. They've got a $40, $50 one, which is, you know, basically the same exact thing, but it's inside a case. But I think you can also buy a little acrylic case for this for maybe 10 extra bucks. But, you know, I'm just going to leave it like this or come up with something myself to put it in. But, yeah, so far, pretty nifty. But only downside is I wanted to mention that this test signal was not working for me properly at first. It was only barely picking up in the 10 millivolt scale. Along with that, I was not able to get a proper voltage reading on a 9 volt battery. It was showing me something like 1.5 volts. And I thought maybe something was wrong until I realized that it was all in the probe leads. Some type of way, the way those probe leads were fidgeting around with them enough, got them back into working functionality to where now my test signal was reading properly. So nothing was wrong with the signal. It was the probes. Not really sure. Maybe I just need to get some better ones. But yeah, I guess you shouldn't really have a whole lot of faith in these cheap ones that come with it. But they do work. But if you do have a problem, I would say first put a multimeter on your test signal to see what you're getting there. And if you're getting what you're supposed to be getting on the multimeter, then as far as the voltage goes, then you probably got something going on with your probe leads. So, I don't know, fidget with them, play around with them, you know, maybe you'll see a difference. Alright, as far as the calibration goes on this test signal, you've got this little explanation here. It basically says, you know, put it on 0.1 volts sensitivity x5, and at 0.2 milliseconds, that's what your waveform is going to look like roughly. And what you're trying to do is trim down that little whisker coming off the bottom end of your square so that it's flat, generally looking like that right there. Now that doesn't look perfect, but it's close enough, whereas that's got a little bit of a roll off. So you can see I've kind of already done that here, but you're supposed to be able to adjust this C4 capacitor here. So you can see if I move it back, that I've got that whisker there. Now if I just kind of finely dial it back, I can get it roughly about flat. If I go too much, I start rolling it over. So I want to get it to about flat right there. Right, so that looks pretty good. So now it says bump the sensitivity. So now you want to go to 1 volt x1. So we're at 1 volt x1. Now you can see that little whisker there. Now you're supposed to be able to trim that back as well with this C6 capacitor. However, was not able to successfully do that. You can see it kind of jumps around. There's really nowhere you can trim this back to where you're going to get rid of that little whisker there. But if you kind of fidget with it enough, maybe you can sort of find a relatively satisfactory point. And, you know, I mean, I'm just going to leave it alone right there. That's not a huge deal. It is actually jumping around close to about 0.5 volt there, but whatever, I can't do anything about it. This thing is cheap. What do you expect? So that's that. But yeah, like I say, back to the test signal. This was not picking up properly at first. I don't know what's going on in that probe, but I'm gonna have to get a different probe because I can't really trust what that's doing. As far as the waveform itself goes, I can sort of generally trust that, but the amplitude, the voltage that it's showing me, not so much. So also, let's see, let's go back to DC here. So 3.3 volts. I believe if I needed to calibrate the offset there, I've got this little arrow highlighted. If I hold down the OK button for 2 seconds, see what it did there was it just calibrated, it just calibrated this square wave on DC mode to where the 0 point volt is just basically cut it in the middle. That's not what I want, because this is in DC. That's kind of what I want to be showing in AC, which when I switch over to AC, now you can see it's moved the peak of the positive end of the square to the 0 volt point. So now it almost kind of looks like what I'm looking at here is a pulse DC that's all negative square wave, and that's not what I want. So with this highlighted, just hold the OK button again for 2 seconds. And now it's calibrated that back to where it's supposed to be. Okay. So, you know, little basic things like that go into, but I guess the main thing for me was just the probes. But that's generally what you're going to get. And for the type of measurements you're probably going to be doing with this basic single channel scope, I mean, that's about all you really need. I think it's a pretty good deal. And yeah, nice little screen. Refresh rate is pretty pleasing. But yeah, everything about it pretty handy. I like that this is available.